Hi guys, this is my little pencast on accumulated probability. I'm having to work fast with the stylus just to keep the flow going. Alright, and so it's page 315. Alright, well, part of the trouble was definitional really, and you need to have them worked out before you start illustrating, so I'll do exactly that. Okay, so here's it is, the probability of having the first girl by the third birth. Now it's got a complement, hasn't it? And it's easy to identify the probability of not having the first girl by the third birth. Okay, your intuition should be telling you that should all sum to 1. Alright, well look, this is what we want to do. If we can find the probability, if we can find the probability of this term here and take it away from 1, then what we're going to do is we're going to find the probability that we're after. That makes sense, doesn't it? Alright, well, can we do that? Oh, yeah, look. Okay, so here's the first birth event. And the outcome's going to be a boy. Here's the next birthing event, where there are 2 births and they're both boys. Here's another birthing event where we've got 3 boys. Now, what's the probability that we can assign to each of these 3 events? Well, remember, in the general population, for every 100 births, 51 of those are going to be boys. So, the probability of this event is going to be 0.51. The probability of this one is going to be 0.51 times 0.551. The probability of this one is going to be 0.51 times 0.51 times 0.51. And that's okay. So it's this probability here, isn't it, that we can assign to that statement. Another way of writing that is 0.51 to the power of 3, and when you do that, I get an answer of something like 0.133. Right, when I take it away from 1 minus 0.133, what do I end up with? Well, let's just go and do it on my trusty calculator. 1 minus 0.133, and I get an accumulated probability 0.867. Now, this probability can be assigned to this statement here. So the probability of having the first girl by the third birth is 87%. It's almost a certainty that you're going to have a girl by the third birth. That's what that's saying, isn't it? That's pretty snazzy. Alright, well, can we actually go and check that this is the right answer? Okay, well we can. So let's just go and turn the page. Right, we've turned the page now, and so let's just go back to a single birth event, and what's the outcome going to be? This time it's going to be a girl. Let's look at another birth event, and this time 2 births, and it's going to be a boy and a girl. And the third event is going to be 3 births. It's going to be a boy, and a girl. So what's the probability of each of these events? Well, that's going to be 0.49, isn't it? That's going to be 0.51 times 0.49, and that's going to be 0.51 times 0.51 times 0.49. What are these? That's going to be, that one's going to be, what's that going to be equal to? 0.2499. What's this one going to be equal to? And it's going to be equal to 0.1274. Okay, what about when we add them up? I mean, that's going to be the test, isn't it? Do they agree with that calculation we've done? Well, let's just go and have a look, guys. That'll be 0.49 plus 0.2499 plus 0.1274. Hey, didn't we do well? The answer is 0.8673. Yeah, we're in total agreement. Is there another way that we can conceptualise this? Well, yeah, there is. The old decision tree is not bad. So here we are at the start. And we can have a girl. That's good. Or we can have a boy. Now, if we have another try, we might get a girl, and we might get a boy. If we're heading down this path, well, then we want to keep trying, don't we? Agreed. Okay, so here we go. We might get a girl, and we might get a boy. Okay. Well, that looks to be pretty clean, really, because we've got all those outcomes identified. So let's just go and assign some probabilities. So this one here, it'll be 0.49. Tracking down here, it'll be, what's that going to be? It'll be 0.51 times 0.49. For tracking down here, it's going to be, what's that? 0.51 times 0.51 times 0.49. Yep, that's okay. That's good. And what about if we track all the way down here? Well, that's going to be 0.51 times 0.51 times 0.51. Ooh, it's a beautiful thing. All right. So what have we got? Okay, so the first branch is a girl. The probability of that's going to be 0.49. The next one is our little red approach, and so that'll be boy, girl. So that'll be 0.51 times 0.49. What about that next approach? It'll be boy, girl. So what we've got there, that'll be 0.51 times 0.51 times 0.49. Oh, this is getting good. And what about that last one? Well, that'll be boy. So that'll be 0.51 times 0.51 times 0.51. Oh, that's great. And look, if you calculate all these probabilities, I'm not going to do it, I'm going to get you to do it, and you sum them, they'll equal 1. So, can you see, this is the conceptual insight thing that I wanted to give you today, but couldn't. What we did is that we calculated the probability of this, and took it away from 1. In other words, we did 1 minus 0.133, and then that gave us that answer of 0.867. So what I'm saying to you, it'll come as no surprise to me, is that when you add these ones up, you'll get that 0.867. Right, well look, I'm gonna leave that with you, or am I? Oh, well, there's just one more thing to do, isn't it? The development of that formula. Can we develop it? I'm doing this on the fly now, always dangerous. Okay, so Yes, we can. So what we've got here is that start. So you can have a girl, you'd stop there. Alright, here you'd have a boy, and then you'd have a girl, so you'd stop there. Here you have a boy, and then you'd have a girl. Or you might, on your third try, you might end up with a boy. Alrighty, so how are we going to do this? Okay. So, for each of those probabilities, what we can do is we can go 1 minus p, 1 minus p, 1 minus p, and remember we're multiplying them together. So that'll be 1 minus p to the power of 3. And so what we want to do now is take that away from 1. And that's going to give us our accumulated probability. What we can do is we can just generalise the formula, haven't we? Because what does this 3 represent? It represents 3 births, doesn't it? So we could rewrite this 1 minus p to the power of n, where n is the number of births. Well, look, did you get there? Well, I hope you did. But I'm just trying to explore the wonderful world of statistics with you. Okay, catch you another time.